Hello, and welcome to the latest JuliaHub webinar, Breaking Boundaries in Data Science, introducing next generation analysis and visualization. I'm Sanjeev Dasgupta, Marketing Manager at JuliaHub. I'm today joined by our presenters, Deep Datta and Phil Vernes. Deep is JuliaHub's product director, and Phil is our sales engineer. Um, Post the webinar, we'll open the session for Q&A. You can post your questions in chat or also ask it directly to one of our presenters. With this, I'll turn things over to Deep. Over to you, Deep.
Yeah, thank you. Hi, everyone. Welcome to the JuliaHub webinar. So today I'm excited to tell you a little bit more about how we think about data science and specifically data visualizations. So with me today, I've got Phil. So we'll do some super quick introductions. As Sanjeev mentioned, I'm the product director at JuliaHub. My email is right there. So if you definitely, if you have questions or feedback about JuliaHub, the product, the experience, please definitely email me. My esteemed colleague, Phil here is going to be leading the technical demo portion of the webinar. Phil, is there anything you'd like to say to the audience?
No, it's going to be an interesting webinar. I hope people get a lot out of it. Thank you for coming.
Awesome. All right. So our goal with this presentation is to help you understand how JuliaHub can aid you and your organization with data science, so your teams can make breakthroughs in whatever scientific, numerical, or computing and technical fields that you're experts in. We want the data communication piece of what your team is doing to be very clear. And we're hoping that through this webinar, you're going to get a few things out of it. So during the demo, you're going to see all of this, but you'll see, how to get data in and out of JuliaHub. Then we'll be showing you a number of Julia-based packages and libraries that are perfect for this kind of thing. So Phil will show you how to explore and transform that data using some Julia packages. There'll also be Julia packages that help plot and customize that data. And then to end out the experience, we will show you very quickly how to turn that information into a dashboard visualization app. Before I jump into the content of the demo, for those of you that are a little bit new, I did want to give you sort of a brief overview of what is JuliaHub. So JuliaHub is basically, it's a platform for all things Julia. Where we are right now is we're really focusing on, helping scientists come together with developers to build out and validate technological and scientific breakthroughs. So a lot of the features on JuliaHub are focused on things like numerical analysis, high performance computing infrastructure, and more modeling and simulation tools. So some of the features that you're going to see in this particular webinar are going to include something we call JuliaHub projects. Projects is really just a way to encapsulate resources and help different teams get access to those resources. So within the scope of a project, you can actually set access controls and you can say, hey, I only want these 5 members of this project seeing, the resources for this project, versus maybe you have folders and files and, proprietary packages that you want to have a different team member look at. So that could be part of a different project. Some of the other things you're going to see in the demo are how JuliaHub handles datasets. JuliaHub also has a viewer for files and folders. And some of the applications that you're going to see in the demo include Pluto, which is similar to Jupyter Notebooks. It's a reactive notebook used for scientific computing. You're also going to see the Julia IDE experience launched in VS Code. And Phil, of course, is going to walk through the actual use case of using some of the data science-based packages in Julia IDE. And last, you'll see the actual dash.jl package, and I'll explain what that is when we get there. But basically, you're going to see how to build a very simple web app that has these data visualizations. I do want to mention that JuliaHub is a free to use service to start. You can just go to juliahub.com. You can actually follow along in this demo right now today or later when you're watching this. Easiest way to do that is just go to juliahub.com. you can click on the Start for Free button, or in the top right-hand corner, there's a little person icon. That's actually going to help you log in using a identity provider, and it's very easy to get started. Okay, so let's talk about the actual content that we came to see. So one thing we want to answer for you, really the main question is, how do I use the Julia ecosystem of tools for data science visualizations so that my business stakeholders can understand what's happening with this data? To walk through this content today, we're going to tell a little story. So in this story, we have a business intelligence developer named Arnie. And Arnie is basically a scientific coder at his organization. He helps the scientists at the org build and validate, data-rich applications. And in this particular scenario, Arnie is going to help validate some information that his scientists have collected, data about the natural world. So the problem that Arnie is trying to solve, every day really when he gets to work is how to quickly take the powerful data outputs that his scientists have developed and turn them into insights that can be easily understood by, business stakeholders. To solve that problem, Arnie has sort of been made aware of JuliaHub. Arnie is a Julia developer, and he's really, here to understand how to build a workflow that helps him build these visualizations for his team. So Arnie's research project today is to figure out how to get all the scientific data, the data that that his team collected from the natural world, and build out sort of a visual way to communicate that data. He wants everything that he's doing in this project to be trackable, so that he can, go back and audit and work on it later, that this information that he builds into JuliaHub can be audited and optimized even in the future. So a lot of working in JuliaHub is giving Arnie the ability to basically track and audit and go back and reuse a lot of that work. So now what I'm going to do is I'm going to talk a little bit about some of the features you're going to see during the demo, because my colleague Phil might run through some of them quite quickly. So Phil's going to start showing Arnie how to do this work, and he's going to start with this concept of projects, as I mentioned. Projects is a way to create a folder and file structure. You can then upload your data sets, your code, your artifacts to those files and folders. And all of this information is then trackable. Projects has Git behind the scenes, so everything can be version controlled and rolled back. So the first thing that Arnie is going to do is that he's going to ask Phil to show him how to start a project. And the other things that Arnie wants to understand is what are some of the common packages he should build into his data science workflow. So today, during the demo, you're going to see these packages. You're going to see data frames, which really helps Julia community explore the data in a tabular format. It makes it much easier to work with that data in various forms of code. You're then going to see, you're also going to see the CSV package, which helps us read and write to CSV files. You will see the plotting package, plots and plotly. You're also going to see packages that have to do with JuliaHub specifically. And at the very end, you're going to see Dash, which is the framework that helps us build our very simple web visualization app. Now, I want to show you one or two things that are kind of important, I think, to the JuliaHub and Julia ecosystem. So one of the big ones to pinpoint is the data frames package. So data frames helps you read data from whatever format you have, maybe on your desktop, let's say. And once the data frames package has read that data, it actually gets pulled into your session, your JuliaHub session, and it's stored there. And it's stored in a way where you can manipulate it with, the data frames code. But you can also use this to keep that data persistent in its state and basically add it to other applications and projects that you're working with in the future. So the way that kind of works is you basically, in this example that you're going to see today, you're going to take CSV data You're going to write it into the data frame. And in this example, we're calling the data frame DF. And basically, we're assigning the output of what is read from the CSV file to this data frame DF. The next thing I'll briefly mention before the demo is what Dash actually does. So I just wanted to give you a quick screenshot. The app that Phil is going to be helping build for Arnie is based on Dash, which is a framework. And Dash comes with these beautiful pre-built templates, as well as pre-built web components that help you create plots, create different kinds of graphs, create drop downs and sliders, and you're going to see a bit of that today in the demo. So we're going to get to the demo in a minute. Just kind of want to give you a sort of introduction to what you're about to see. So what Phil is going to teach Arnie is how to build an end-to-end data workflow that takes the raw data that Arnie's computer science, that his scientists have given him, and actually makes this data actionable for his business stakeholders. So what you'll see first is Phil is going to spin up a project in JuliaHub. This is going to make sure that these resources persist across the scope of the project. Then he's going to show you how to get data into JuliaHub, upload that observational data. He will spin up the Pluto reactive notebook environment to explore the data, including bringing in some Julia packages that are going to help with that exploration. He will then plot the information and show you how to customize those plots. And then sort of step 2 is he's going to take all this exploration. He's going to spin up the Julia IDE experience, and he's going to show you sort of, how the Dash framework actually takes that information and turns it into a very simple web app. Okay, so with that, I'm going to hand it over to Phil. Thank you.
Wonderful. Thank you, Deep. I'm going to share my screen now. Let's see. Yeah. Let's do this one. All right, great. So we have to start from the top here. So first of all, thanks for attending. I'm Phil Vernes, sales engineer at JuliaHub. I don't know how many of you have actually used JuliaHub extensively. You may just be Julia developers, or you might already be JuliaHub users. In any case, when you log into JuliaHub, you will start in your home, right? And you'll generally see, this is a default view that I have, the IDE and Pluto notebook. We're going to use both of these. But before we get to the IDE, and before we get into Pluto, we have to first create our project. Now you see I have an existing project here. If I were to click on it, you're going to see that there are two components. There's a data component and then the coding component, right? So if you were to look at this little sequence of circles, click here on this arrow, and it expands and it gives you the metadata of this data. As you can see, the name here is my username, and then the dataset name here is CSV data. Now, what does that mean? When you store data in JuliaHub, and you use JuliaHub user, it will be stored with respect to a user. So it does not go into a particular file system. Why am I talking about this? Because when we use the API, it will be very important that you either upload the data yourself, right, which you would do right here, or someone gave you access rights to that data, right? If neither of those is the case, then you will not be able to access that data set through the API. Now, to give you an idea of what the data sets look like when they're sitting in JuliaHub, I can click here. And this is just some of my data sets. This is from an mRNA sequencing project I did earlier. And you see they're all under my name, and there's no real nesting of any sort, right? They all just sit here. So if I want to pull a data set that I've put under me, this was from a different project, by the way, I have to do it through my name, and that suffices. Okay, so now that you're familiar, the other thing I want you to notice too about these data set names, not a single one of them has any sort of suffix, right? This is actually an HT5 file, right? There's no indicator of that. That is not included in the data set name, the file extensions. So again, you need to be mindful of that when you're doing the bookkeeping, when we're working with data sets, because you're going to go from a data set in JuliaHub to either a Pluto instance or your VS Code instance or even a commit or a REPL, and you want to make sure you will very likely want to include the extension to work with these files. Okay, I'll go back to the projects now. So if I were to create a new project, I'll just quickly walk through this. I would have to specify a name and say dummy project, because I already have one existing. I don't want to create a new one right now on the fly. Descriptions and tags. This is neat. You can actually have concurrent editing like Google Docs, so multiple people can be in the same project and it's stateful, which is great. Then we have collaborators. This is actually really important. When he talks about general access, it's talking about within your organization, right? So practically speaking, that's saying if I am independently developing something, it's not ready, I don't want people looking at it yet, you would definitely want to leave it at no access. If on the other hand, you're basically ready to publish the code, for lack of a better word, or share with other people, you can set either viewer or editor rights. And then finally, there's resources, which I alluded to earlier. I can click add project resources, and it partitions them between either a code resource, and if I click add folder, then a dataset resource. Okay, so there's a slight distinction between how, say, VS Code works, right, where you just have directories, and how JuliaHub works. So if you have questions on this, we're going to walk through the example, and it might clarify things, especially when I do some API calls using the JuliaHub package. All right, normally I'll click create project, and it would generate an empty project, and I could add resources accordingly. Let's get to it. Let's go into a Pluto notebook. Now, this one I've already opened for the sake of time. And first thing I did in my first command is I said using JuliaHub. Now, what is JuliaHub? Now, this is actually really important. This is something it's very good you came to this webinar, because I can actually tell you something very helpful. This JuliaHub package, usually the packages are named like package name.jl, right? No. This is not the case. In fact, I was looking up documentation to confirm something earlier. It's actually called JuliaHub client 2.jl. All right. So if you ever, what I love about open source code is you can always, the code is your documentation. It's just out there. It's wonderful. So if you want to look up any of the source code or get, just double check something, how something works with the JuliaHub package, you can actually look it up by going to this repo in GitHub, and you'll find it, JuliaHub client 2.jl. So, and like I said, I have it open here, and I was looking at the data sets just to test a few things before our call. So this is extremely important. Why? First of all, it's a novel package, and secondly, it takes care of a lot of bookkeeping for you that normally you'd have to do automatically. It checks access rights, it manages, it takes care of data sets, it can handle all sorts of API calls. You can do you can send scripts to a JuliaHub instance. Like you could literally code JuliaHub code and have it be dispatched to your JuliaHub instance and have it execute. All the basic CRUD features you need, you can do with the JuliaHub package. So in terms of an API for interfacing with your JuliaHub organization, it's indispensable and it's very important. So that is actually my primary objective. One of my primary objectives is to familiarize you with the JuliaHub. Then, of course, there's data frames, CSV, and plots. These are all fairly, I think, self-explanatory. The only thing I want to say is about plots is that we are going to, in this Pluto notebook, I'm going to do something interesting where I'm going to use the plots.jl front end with a Plotly backend. So in Julia, it is entirely possible to have what you can call a more unified front end for plotting, and plots.jl actually supports that. So if, again, there are questions on that, we can talk about that more at the end, but there is a, I hope, and maybe time will prove it out, but I think there is a consensus that it would be a good thing to have a more unified front end for plotting. So, for example, I can use plot. In this case, I'm going to use plots as my front end, plots.jl as my front end, but I'm going to actually use Plotly as my back end, right? This gives you very good flexibility. There are other plotting engines that work with plots.jl as a front end. I know GR is one of them, and there are a few others. So let's get to it. So the first thing I need to do is I need to acquire the metadata. Recall, we talked about the data on JuliaHub. I need to acquire the metadata about the CSV data in my project. So if we go back to my project, which is here, we see there's data, CSV data. I want to access that. This is sitting in my project. I upload it from my local drive, very easily clicking here and just uploading it. I want to read it. I want to work with this CSV data. That's from some experiment, from Artie. Okay, great. So how do I do this? I need to create a reference to that CSV data in JuliaHub. And it's interesting too, if you look at the type, it's a type of blob. It's not storing in a CSV file. There's, again, another distinction, right? You would think, well, I uploaded a CSV file. It's the type. No, the extension, that's true. The extension is not being recognized as being treated as a blob. That's actually correct. This is working, okay? Again, this is the metadata of the data itself. And if I actually want to show the code for that, it's a simple one-liner right here. So I just create a data reference. I use a JuliaHub package, the dataset function, and the name of the dataset itself. Now, if someone were to share the data with you, like, you know, if Joe Blogs shared data with me, I would have to put his name here first, right? But this command would only work if he gave me access rights to this, to CSV data, right? So I just want to repeat myself. If this were not sitting in my project, right? So I automatically have owner rights. If it were someone else's data set, I would have to, that Joe Blogs, he would have to give me access rights to that data set before this command would work, okay? So that's the only thing I want to mention about the data reference. So once this data reference is built, I do not download the data yet, okay? I want to be very explicit. I have not downloaded the data yet. I have built a reference to the data set in the JuliaHub API, right? Now, it's kind of skipping ahead, that's all right. The next thing is, this is showing the output of what I'm going to explain down here. When you're working in Pluto, this is just an aside, whenever you do and many of you are probably familiar with this, but for those of you who are not, if you have more than one line to evaluate, you have to start it and terminate it with a begin and end. That's all. Now, I want to access this CSV data entity in my JuliaHub, and I want to read it as a CSV file, right? And I want to make it that CSV file into a data frame. And so I have to answer two questions, which is, number one, is the CSV file already there? Because in fact, if the CSV file is already there, then downloading the data set, which is this command, right? So here in this command, I'm creating a reference to the data set. In this command, I'm actually downloading the data set, okay? And it's going to go to my absolute path, whatever that is. So I always do this command. I say, okay, get my current directory, my current working directory. I need to know it. I need to know it because when I execute download dataset with these arguments, it's going to put it in my current working directory. Okay, so I check my current working directory and say, is this file already there? If it is, skip it. If it's not, then execute this command. So then I will download the dataset with the data reference defined as up here, and this is where I specify the file name. Okay, so I do not put CSV data.csv here as if that's what I'm looking for in JuliaHub. I'm specifying the file name that I want to write it, or as I want to write it, to which I want to write it. Okay. Then finally, as Deep very well explained earlier, this is constructing a data frame using the very standard CSV read package, the CSV package and the read function. And again, I have to give a path. So I use the absolute path, which I got up here by getting my working directory. And then these stars, by the way, are concatenations for strings. Now I know in Python, you might be used to something like A plus B or something for concatenation of strings. But in Julia, if I'm going to, cat and dog, right? This won't. This does not concatenate. You would want a star here. So just that's all that is. If you haven't done string concatenation, syntax looks weird. So this command, this block of code, gets me my data set. Now, if I look at this data set, I say, okay, gosh, it's 100 rows. Let's see how I can evaluate a more succinct portion of it. There's some nice functions, and you see these in other languages too, like R, Python. Say, okay, first of the data frame, first 6 rows. Okay, as I got the first 6 rows, this is looking like binomial data here of some sort. This is looking like some sort of I don't know, maybe a beta distribution, and this is looking gamma-ish if I had to guess. And it's a guess. But this is definitely fat tail for sure. And I also want to check to make sure that this data frame I brought in is actually a data frame. So I use a type of command. Okay, very standard. And it's the last sanity check. I look at the last 3 rows. Okay, nothing weird. This is not a comprehensive check yet. This is just the first, what I would call the basic sanity checks. Now, as already spoke about before, we're going to use the plots.jl front end and the plotly back end. The documentation does both of those is available right here. And when I invoke the plotly backend, I have to do so explicitly. So I would say plots package, and there's a function called plotly, right? No arguments here. When I do that, and execute that, it's invoking the plotly backend. So if you were to look at the, maybe we could, if we had time at the end, maybe I can do this or answer questions, but you can look at the type of plot generated by plotly, excuse me, by plots.jl with the plotly backend. And it's quite different than the type of plots of plot object generated by plots.jl on its own. It's a bit of a tongue twister right now. Okay, now let's start playing with actual plotting. Now this is using the plots.jl front end with the plotly backend. How do I know that? How do I know it's plotly? Well, here, produce with plotly. Okay, that's a pretty good guess. So this is pretty canonical. Like this is your basic histogram function. So I would say, okay, histogram data frame. We had a D1 as a first column, D2, D3. Okay, fine. Very standard syntax here. We plot a data frame, we plot our data frame using a histogram. We set our bins to this thing called bin number underscore D1, and our labels are D1 for our legend. And then this title, I can do this after generating the chart. I can actually update this object with this by having this ampersand after the function, and it updates this plot to give it a title histogram D1. And now here's what's interesting. Because we're in Pluto, you would think, where is this bin equal bin number D1 coming from? I didn't define it anywhere. It's actually defined down here. I defined a binding. Now this is called the @bind. This ampersand means you're invoking a what we call metaprogramming function, we call macros. Macros are a code that generates code. So the code, so when I write @bind bin number D1 HTML blah 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 blah, this is not evaluated in the same way as say this code or anything else, right? This will first generate the code, and then it will be evaluated. So it's a different order of operations, and it's a very powerful tool. It's under metaprogramming. We have extensive documentation on it. I highly encourage you to read it. But with respect to Pluto notebooks, what's again interesting is this is not synchronous, right? This is defined, this plotted, but this is down here. Yes, because the way Pluto notebooks work is that it reads it. The order in which it is written does not matter. So even though this is after, it still works just fine. Normally, if you did this, say in VS Code or any other in a REPL, it would not work because it's not defined. But it's actually the state is distributed, not necessarily line by line, but across the entire page all at the same time. So just to repeat, you don't. It's not, and this is important for Pluto notebooks. I've actually run into this where sometimes you're mutating a variable somewhere else, and you still are thinking in terms of sequential coding, and it causes an error way upstream. But there is no upstream because everything is evaluated, I guess you could say, at once. I'll be very vague because I don't want to go to that conversation. Here, this is a more conventional evaluation where, again, we're using this macro @bind to allow me to adjust the bin size for this second histogram. This is really nice because when you're doing diagnostics, especially for the distribution of data, this will allow you to kind of sniff things out. I personally like histograms. I like histograms and box plots. I didn't bother box plots here for the time, but I like histograms. And I think, in your statistics textbooks, the ECDF and empirical distribution functions are used extensively for a lot of important things like, bootstrap and stuff. Okay, let's keep going. For D3, the histogram for the final distribution, I didn't bother with the thing. I've already elaborated on that. Now, what's going to happen here is now I'm going to jump into the more sophisticated plotting layout. In this case, I will change my type of my data frame. I will convert it into a matrix. So this is now a matrix data type of 64 floats. So it's really easy in Julia to do this. You just say matrix data frame. So you have your data frame entity, you could cast it now into a matrix. Usually you could also use a convert function. That's very standard, but you'd have to specify the type of matrix. You'd have to literally put matrix 464 for your type. Here, it does it for you. It's just a nice convenience function. Now, I'm starting to plot here. I say, okay, I want to get an idea. I need to start thinking about how I'm going to share these histograms with people. And I want to get an idea of how they look relative to one another. So I put them all in the same plot. These are subplots. Now I use in the plots.jl, I have something called layout attribute. I set it to 3, and that means it will automatically arrange 3 subplots in this given plot. However, this really doesn't look ideal, right? Like you would think that this is taking a little too much real estate given how valuable it is. And this one, you would maybe want to say have a slightly different distribution of the plotting surface area for these 3 different plots. And you can do that very easily. You just specify the heights and weights. So you have this grid constructor for this layout property for your plots. And this is all the plots.jl API, by the way. So I'm talking about the front of plots.jl, not Plotly. We'll touch Plotly a little bit towards the end. Plotly API. So I have a grid constructor here. I say 2 by 2, so that's 2 rows, 2 columns. And the indexing is row major. So you go through the first row first and then the second row. And I set the heights at 20% for the first row and 80% for the second, and 80% for the first column and 20% for the second. And this is the result. I also toggle the colors. And it looks pretty nice, right? Now I have more space for this chart. The coloring is more interesting, but I really want to put this chart down. So I use the old trick, which is I create a dummy chart, an empty chart, which is, I think, pretty commonly known trick. And now I have the arrangement I want. So you can see here, I have a plot command, which is the plots.jl canonical command. I specify my layout, the heights and widths. I suppress the legend. I plot my first chart. I plot my null chart. I plot my third column, because that's the one I'm interested in most. And then I plot the second column of my matrix data here, and I have a nicer distribution. So the range is more extensive. It's not as squished as it is up there. A little more insightful. Now I say, okay, I want to try something more fancy. I say maybe I will try, a surface plot, right? I could go something like this. I can toggle the fill. Maybe it's just maybe make it a little darker, right? And okay, wow, that's great. But the data, as we can see, it's not very insightful, right? You have this like binary data, and then you have this like continuous numerical data, and this surface chart, as interesting as it is not terribly insightful. So I say, okay, let's construct a scatter plot. Again, using the plots.jl API, what I do is I kind of look at it as a projection, right? So my third dimension now is a binary indicator variable, my D1 value. I'm going to treat it as a categorical variable. Now, this is a nice trick to know. If you're dealing with 3-dimensional data, but one of the data is basically, it might be a number, but it might basically, you can treat it as a categorical variable. This is a nice thing to do. You use in the plots.jl API, you define a group. And in this case, I actually do use a convert function. I convert my group, and the only reason this is just to be pedantic. I could probably not use this. I convert my group, which is a matrix data of floating point numbers. They're all zeros and ones, but they're still floating point. I convert it to an integer. And it gives me a nice legend here, and it indicates for each point here, what point has obviously 0, 1. So I have my 2 dimensions here, and I represent my third dimension with this legend. So I can treat my very low cardinality numeric data as a categorical variable, and that's how I did it here. Of course, I specified my chart type as a scatter, and this is called a symbol representation. If you can look that up, but the reason why there's a colon in front of this name is because it's a symbol. Right, so it's not a string. It's different. Again, go into the documentation. Want to look up how symbols work in Julia and experiment a bit. They're quite interesting. And then finally, I specify the X and Y label and a title for the legend, which is quite instructive. Now, to contrast that, if I were looking at a third dimension that was continuous, which is not the case here, I might want to use the Z color, right? And again, I cast it here to an integer to try to kind of wedge it in, because I was trying to fool this bar here. It didn't really work. You see, you have the same information, And by the way, what I really like about Plotly is it gives all this, I mean, look at all these coordinates, right? It's kind of cool. You have the same information, but the presentation is not quite as suitable as this one. So again, low cardinality, three-dimensional data. You can represent it with a 2D with a categorical variable. I think that's nice. So now the question is I have these insights. This is wonderful. How do I share them with people? And I'm going to walk through a very, very simple example using Dash. And what Dash is Dash is a framework, like any other web framework. And my focus here is to help people who are not developers, like just people who are BI analysts, people who may have used no-code or low-code tools, people who are getting, who want to expand their abilities, right, to just do something a little more. And one of the advantages is that when you share a Dash application, instead of having to give someone access to this notebook and maybe you restrict that person's access rights or whatnot. Yeah, this is really cool. Zoom in, zoom out. It's really awesome. You can actually create an application, right? So you can actually create an application, and by that I'll show you concretely what you can eventually do with Dash. If you're to go to your home, you click here on applications, you could essentially add an application. We're not going to cover that in this session for a long time, but you can actually add your Dash app as an application, and then that application can be available within your organization, and you have a very controlled environment with which to share information. Okay, so that's kind of the long-term goal of using Dash as an individual contributor, is that you can disseminate these insights and create an interactive dashboard across your organization without having to share code or actual raw data sets. Okay, so let's go look at Dash. So to get here, this is my VS Code instance in JuliaHub, but I have to get here, right? So how do I do that? Well, I clicked here, so that's not how you're going to do it, right? You have to go to projects. When you go to your project, you're going to want to go to connect, and here connect to Julia IDE. Okay, you want to do that within your project itself. You don't want to do it. Say, I'll give you a counterexample. You want to do it here. You don't want to do it here. Not that it won't work. It's going to take you to somewhere else, right? I want to be in my project folder. I want to be looking at this. And this is my project folder. And today I have two demos, actually. I have the full demo and I have a minimum demo. And I want to walk through both because they have slightly different learning objectives. In my minimum demo, I'm going to introduce Dash. This is the package that allows us to work with the Dash framework. I'm also going to use Plotly.js. That is only to simplify a few of the things I had to do otherwise. But in the future, I would anticipate all working through plots. But right now, I'm still using Plotly.js rather than using the plots.jl, which I used here, right? I'm just going to use straight Plotly.js. So this would be a Plotly front-end API with a Plotly backend. Okay, so the charting commands will seem a little different, but I think you should all be able to follow along. Then I'm using our sockets package to obviously be able to connect ports, CSVs for obvious reasons, and these are usual suspects. So one of the things I'm going to do is when I create a Dash object, right? I have to, and we call it app. I have to first specify. I have this very standard format, which is for Julia, you're going to always use the same command, and you can, in this case, this is actually superfluous because in this case I don't really need an external style sheet, but you generally will specify an external style sheet as your second argument. In this case, assets. So if you see here my Dash code, if I click here, I click assets, my CSS sits here, right? So it's in the subdirectory for my dashmin.jl file. So when I create this this app, I can actually omit this. So for the minimum example, I can actually get away with this. I actually don't need this. I'll definitely need that in the next example. So great, I created my Dash instance, but I also note that I had to interpolate the port because I defined the port up here. That's very standard. Now, if you've never done any sort of like local hosting or developing any sort of apps, you need to know that you have to assign a port, and hopefully nothing else is using it. Otherwise, it will report a collision. I still also need to get my working directory because yes, I am using Dash, but I'm also using data. And I'm using the same data set that we used here, right? So guess what? Good news, same commands work. So I could literally, if I wanted to, let's see here. Where's my command? It's right here. I could copy. In fact, I did. I could copy and paste this code right into here, and that's really what I want to get people to understand, is that you can use your Pluto notebook not only to share insights, but also as kind of like a REPL, right? To wrangle the data, get your hands around it, and then the commands that work there for the data sets when working with the Julia API, guess what? They're going to work here, and they do. So I build my data reference, I get my working directory, I check if the file is already there, and I download the data set, and then I make my data frame. Okay, that's all been done. Now, this is where things get a little different. I'm going to define a histogram using the Plotly JS API. So it's a little different. This is kind of reminiscent of R in some ways. But like I have here, I say, okay, this is that colon thing. If this is unfamiliar to you, how this is working, please look up Julia documentation about symbols and how symbols work. It's really interesting, and it's once you get used to it, it's fun. But if this is weird, if you think it should just be this, please read about symbols. Okay, it'll help you tremendously. And as we recall, like, what is this? This is a column name. Like if we go back here, this is D2, right? So I'm referencing that column. Okay, let's go back here. Specify the type, and then I'm also specifying the number of bins. Fine. This is very generic, not particularly exciting, but I can actually execute this line by line. Now, this is what's really cool, is when I'm in the IDE, even though I'm in the IDE and I have the following options for executing the code, I can click here and say, okay, as in the REPL, run a new process, or run debug. We're definitely not doing that today. I can actually have another option, which I've learned is quite useful, is I hold down Shift and Enter, and I run the code line by line. And this is pretty neat. Looks good. Obviously, now this obviously did not execute because you can see the CSV data is there. So yes, this did not execute. That's good. Create the data frame, plot it. Now, this is where we generate the actual HTML, as you can tell, right? So within the app entity, there's a layout that we're going to define here. In Dash, if you read the documentation, the first thing you build after creating the app object or entity is you define the layout when you start working with it, and this is how you do it. So you have the name of the package, and then you define the main div. So this is, if you were to, this is literally the same as, you know, it is constructed for you. So you're basically building out the HTML, but this is I wouldn't call it the root, but this is the top level div HTML element that you're constructing here. And then when you have this command here, this do, right, and end implies that this is nested. Okay, so these sit below. These are this is a parent entity, and these are both children to this entity. So anything, when you see this do with respect to this whole Dash layout thing, and there's a technicality here about do as well in terms of how the function is evaluated. I don't want to go into there. When you see this do, it implies nesting. Okay, so whenever you're nesting HTML elements, you would have a do. So like if I were to, you know, if I were to add another do, right, like another dash.html div, add another div do, right, I would actually have two layers. So I would be double nesting it. But anyway, so I just want to make sure that when you look at Dash code, and if you look at Dash Julia documentation, it kind of goes into this, but upon inspection your first time, you're like, how does this correspond to the HTML I would write in my editor normally? Just think about this do end. Every time you see that, is a nesting, okay? And then all of a sudden it will make sense. And if you don't know what do end means, kind of doesn't matter right now. Eventually it'll matter, but definitely not anytime soon. It may not have to matter for you, thankfully, but that's a nesting. So let's execute this. Okay, cool. I generated the layout. Now we're going to run it. Let's see what happens. Okay. It should be generating it. What's going on here? Let's try this again. I'll just run the whole thing. Let's see if this is run as a new process. There we go. So while that's running, it may take a moment. Here we go. Oops. That's actually really funny. I actually I added that last. Okay, there we go. Excuse me for that. I had a minor mistake. That's fine. Let's try it again. So the error was that I was missing the JuliaHub package, which actually makes a lot of sense, right? Because if you have the JuliaHub, if I'm using the JuliaHub functions, which is dataset and download dataset, I need to have the package and I need to be using it. So I just added it to the top. So while that's running, it should be executing pretty quickly. Let's see here. I can quickly show you the code for the next one, which is a lot more substantial. In this case, and yes, this one is including JuliaHub, so thank goodness. In this case, oh, wonderful, it's up. Okay, let's go look at it. And there we go. Whoa, look at that. Basic plot. It's a basic histogram. Fantastic. And it's a Plotly one. So when you hover, it gives you these coordinates and, you know, produced by Plotly. Okay, sure about that. Nice Unicode character there. All right, this is wonderful. So this is it. This is the basic minimum thing. So if you are not interested in writing CSS, if you're not interested in writing callbacks or this other stuff, this is enough. This code right here will get you, of course, you'd have to adapt the dataset work and, of course, include JuliaHub, right? But once you get that up, you can just insert all these DCC graphs. In fact, and if you want to see, you could just add as many as you want. So I can just add, you know, dash.dcc graph, you know, ID equals, you know, test2, comma. And by the way, this ID is only relevant when you start talking about callbacks and other things like that. So right now, it's not super. We're not using this ID in any way, but it's just there. And then I could say figure. You need to set the figure property. Okay, so figure is important because the value of the figure property in this case is histogram, which I generate here. But that's where it's going to, that's obviously the figure. So the first one is like, I guess you call it like the handle or whatnot, but this is very, very important. You want to set it to the correct chart. So if I were to define another chart, actually I can do that right now just for fun. I can show you like this. Let's just say D3, and I call this his2. This should work. Right, and then if I were to run it again, this is really quick and dirty. Like I did nothing. I did the basic minimum layout, and I just want to show running two of these in parallel. So first I just need to close this. I can also kill this process. See this little garbage can? I go like this, kill the process. Okay, good. Now I know I'm safe. So run it, and it should show the additional graph. And I specified the figure. In the next chart too, while that's running, I can show you a few things here. So here I build my histogram. It's a subplot histogram. It's a little more sophisticated. So I'm adding traces. I modify it after building it out using the really out function, and then I use it in my figure here as histogram, just like I did here. So it's the same thing. It's just slightly more involved histogram. The only other difference too here in the Dash app, aside from the port number, this is 8229.8117, is let's just open this, see what this looks like for fun. Oh, look at that. See, there you go. Now you have two charts. Wonderful, right? So like I said, if you had to do something quick and dirty, and again, you notice that these are both children of the same HTML element, right? So they're not nested in any way. Just very quick, and if you, something simple, straightforward, no CSS applied of any kind. So yeah, so now this is going to be a more sophisticated example. I'm going to kill this process. See this little garbage can? This is very handy. Under terminals, hear this. Just kill it. Okay, cool. So now I want to look at, again, a more sophisticated case. So one thing I'm going to definitely do here is I'm going to specify a style sheet, which I have here under assets. Now under Dash, make sure to put your style, it looks for under assets. So create an assets folder. The way you would do that is a new folder, type in assets, hit enter, etc., and it would be generated there. Okay. So yeah, put your CSS under the assets. That's where it's going to look for it. That's how the framework is generally designed because you could do it here obviously differently. I mean, I'm specifying the external style sheet, but the conventional naming is assets. So yes, you could call it anything you want, technically. So here I'm specifying the figure. I have one graph element. I don't have two. And if you notice something, I have 1, 2, 3 do's. Okay. So that means I'm going to have one main HTML element. I'm going to have one nested within that. And then I'm going to have another. So these two elements are parallel to each other. The slider column and the plot column, excuse me, the row and slider column are parallel to each other. But excuse me, these yeah. So these are children. These are both children of yeah. So okay. So these are both children of this row. So there's one row under the main element with two columns defined, one for the plot and one for the slider. Okay. So so it's actually the plot column and the slider column sit under two layers. They're not straight after the first one, they're after the second one. It's called class name row. Now these class names are interesting because usually you'd say class, right? Like you'd have a class ID that you use when you're doing CSS. In Dash, very important, use class name. I'll just show quickly what it looks like because I'm running out of time here. If I look at my CSS here, I have like dot plot column, dot slider column, dot plot column, and let's see, dot slider, right? And dot slider column. If I go here, that comes from these names, the class names. So when you're doing your CSS, if you're into CSS, make sure to specify don't use class like you normally would, just use class name, okay? Otherwise, it's not going to pick up the selector. And likewise, even for these nested entities, again, I specify the class name, not the class. You can also use the ID. There's no problem with that, and I don't think that's any different. I just use classes for my selectors. Here, I define now sliders. So now I define 3 slider objects, okay? And each one, and these are all in the slider under slider column, and each of these is each slider has above it a place where I'm going to actually, this ID is actually consequential for my callbacks, because one thing that's going to happen is when you're using, I'm going to start running this just because it takes a minute to compile. When you're using the UX, you're going to generate a number. You want to display that number. That's going to require a callback. So there are two types of callbacks I'm going to have here. I'm going to have a callback for changing the slider and displaying the new value, but I'm also have a callback. If you look at, see, I initialize the bin size here to some constants, but I'm also going to have a callback on the sliders for all 3 of them that are going to generate a new plot, right? If you look at the bin sizes here, D1 bin, D2 bin, D3 bin, these are defined from the sliders. So when I specify here my inputs, D1, D2, D3, my output goes to the plot ID. Remember plot for the DCC graph, ID plot for your histogram. And when you have a callback that's using multiple inputs, you can only have one target. Let me just show you what this looks like. So here we are. Very simple. I toggle the bin size and voila, I now have an interactive chart. So when it comes to callbacks, what's important is when you're working with callbacks is you have to have callbacks not only for the chart, but you would want callbacks. You don't have to, but I like callbacks for the sliders themselves, because when I change a slider value, I want to know what the size is, right? And I can actually do that via a callback. So so each slider has its own unique callback because each slider is a unique target. The plot object here has only one callback with multiple inputs. Okay, so there's one callback for this whole thing with 3 inputs, these 3 sliders, and then each of these 3 sliders have callbacks, but each one is unique. Deep, how am I doing for time here?
Yeah, you're pretty low, so I'd say wrap up right now.
Okay, great. So anyway, the code will be available. I encourage you to play with it and experiment with it. Here's the CSS. It should be helpful for anyone wanting to get started. But we've basically shown that you can have either a minimum example if you want something quick and dirty to help you share your insights, and then you can also make a more substantial interactive application. All right, and with that, I'm going to stop sharing.
All right, thanks, Phil, for that whole walkthrough. That was beautiful. So just got a couple quick slides to sort of summarize what was done. So as you saw, there were a couple packages that were important to this demo: data frames, CSV, plots. You can also use the Plotly backend, and of course we use the Dash for what you saw in terms of the web app. And then there was the JuliaHub package as well. And some of the features that Phil showed you within JuliaHub itself included Pluto notebooks, the Julia IDE, which is a VS Code experience, and then projects to encapsulate those resources. Now, we did a pretty quick walkthrough of Dash. If you want to sort of understand how to build out a more comprehensive Dash app, there's a link here that goes to a Dash webinar that I actually did. And Dash isn't the only framework for building, visualizations and dashboards and web apps. Another popular one is Genie, so I put that link in these slides. As Phil mentioned, we're going to send these slides out as well as the actual code that was demoed, so you'll have access to all of that after the webinar. And just to wrap it up, our goal really, as you're watching this, is for you to be confident that you can do your end-to-end data science workflows all within JuliaHub itself, using packages like data frames. You can manipulate that data, you can plot it using the plots package, and then you can use Dash to build out the visualization tool. So I really want to thank Phil today for going through all of that. I know it was a lot, but you'll have access to the code. I think it'll help you get started. Last thing, we do have a new blog out about the JuliaHub.jl client. This is our first sort of public exposure of how these programmatic access and APIs work. There is a beautiful explanation in there about the data sets, so please check out that blog. And with that, I'm just going to wrap up and see if there are any questions.
Thank you, Deep. Thank you, Phil. So if you have any questions, you can type it in, and we'll pick it up as they come in. Actually. Deep, there's this question someone asked. He says, "Is Dash the only framework to build apps?"
No. So I mean, Dash is just one of many choices. You can basically load up any framework in JuliaHub. So I mentioned, Dash was in this demo, but you can also use Genie. I'm sure there's a number of other sort of open source frameworks out there. We're actually building an entire web server feature in JuliaHub later this year, probably September. And that'll have some pre-built like options like Dash templates and Genie templates that'll launch web apps very quickly. But generally, you can launch whatever you need to within the Julia REPL. Any open source package should work.
Okay. We'll wait for maybe a couple of more minutes in case there are any questions that come in.
I skipped a few things, so if there are any technical questions, don't hesitate. Now's the time to ask.
Yeah, you can either type it in, or talk it out loud.
All right. Any other questions? Otherwise, we'll start wrapping up in a few minutes.
Yep, I think there we have. There's another question. Rita, how do you get extremely large data files into systems like over 10 GB?
Hi.
But by systems, I think they mean. So, Phil, do you want to answer that? I can provide some information too.
I mean, I've worked with large data sets. I never had an issue with it. So I never even noticed it with JuliaHub. I've never had an issue with, like, because I was working with genetic data, the gene sequencing data. I never had a problem. But go ahead, Deep. Maybe you have something more specific than that.
Yeah, I was just going to mention, using the new JuliaHub client, you just hit that endpoint like as an API, and it'll actually get extremely large data into our system, into your instance very quickly. I would love feedback on that. We are looking at other data integrations. Like later this year, we're going to do like S3 buckets, connect to your AWS S3 directly through JuliaHub, and it'll just pull in the data. But for now, I'd say using the API is the way to go.
Thank you, Deep. Are there any other questions? There are no other questions yet. So probably we can wrap up this session. I would like to thank everyone, including Deep and Phil, for this wonderful webinar. The recording of this webinar will be emailed to all the participants. You can also view it on our website once it's uploaded in a couple of days. And we'll keep you posted of our future webinars as we keep hosting them every month. And we would like to see you there again. Thank you, everyone. Have a great day.
Thanks, everyone. Bye.
Bye.
Good luck, everybody.